Welcome to Mr. West class. Today we're going to be taking a look at some fractions that have different denominators and talking about how we can change them so that each one has the same denominator. Let's talk about why we need to do that. Let's take a look at this fraction over here on the left, 1/3. Let's pretend that it was a rectangular pizza. It's broken up into 3 pieces. That's what the denominator means. And then this one over here would be the same size pizza, but it would be broken up into 5 pieces. So over here we have 1/3, that's 1 piece out of 3. Over here we have 1/5, which is 1 piece out of 5. And you'll see that this piece is way bigger than this piece. So we can't really add 2 pieces of different sizes. We can't really compare the 2 fractions when the pieces are different sizes. So we want to change these to equivalent fractions that have the same denominator. To do that, we want to take a look at our multiplication chart over here. And if you have your multiplication chart memorized in your brain, that's great too. If not, you can use your chart. Let's take a look at our denominators, our 3 list, which is right here, and our 5 list, which is right here. And we want to try to find the first number that appears on both of these lists. So let's take a look at the 5 list. See, the first number is 5 on the 5 list, but there's no 5 on the 3 list, so we can't use that. Next number is 10. But there's no 10 on the 3 list, so we can't use that. Next number is 15, and there is a 15 on the 3 list. That means that 15 is the least common multiple, and we're going to use that 15 for the new fractions. Our next step is to figure out our multipliers. How did we get from 3 to 15, and how did we get from 5 to 15? So, by multiplication, how did we get from 3 to 15? We multiplied by 1, 2, 3, 4, 5, so our multiplier is 5. 3 times 5 is 15. Now over here on the other side, how did we get from 5 to 15? We multiplied by 1, 2, 3, so our multiplier is 3. We multiplied 5 times 3 to get 15. Once we determine those multipliers, then we have to apply the numerator to those multipliers. So over here on the left, we multiplied 3 times 5. We also have to multiply the 1 times 5, which is 5. So 1/3 means the exact same thing as 5/15. And over here on the right side, we multiplied 5 times 3, so we got to multiply 1 times 3, which is 3. And 3/15 means the exact same thing as 1/15. Now that we have fractions that have the same denominator, we can add them, we can subtract them, we can compare them. 5/15 would be greater than 3/15. 5/15 plus 3/15 would be 8/15. 5/15 minus 3/15 would be 2/15. And let's take a look at another example. This time we have 1/8 and 5/6. Again, we need to make sure that we have the same denominators. So let's take a look at our 8 list and our 6 list. Try to find the first number that's on both 8's list and 6's list. All right, so the first number is 8, but that's not on the 6th list anywhere. Next number is 16, and that's not on the 6th list anywhere. Look at 24. 24 is the first number that's on both 8's list and 6's list. So let's change both these denominators to 24. And then we'll figure out our multiplier. We got from 8 to 24 by multiplying by 3. We got 6 to 24 by multiplying by 4. And then we apply each numerator to that multiplier. So over here on the left, 8 times 3 is 24, 1 times 3 is 3. And on the right, 6 times 4 is 24, 5 times 4 is 20. Here's a third example, 2/5 and 7/10. Again, let's take a look at our denominators. One is 10. 1 is 5. Let's find the first number that appears on both lists. First number on 10's list is 10. It's 10 times 1. And hey, look at that. It's already on the 5 list. It's 5 times 2. So 10 is the first number that appears on both lists. So let's change this to 10 and this to 10. Figure out our multipliers. We got 5 times 2 gives us 10. 10 times 1 gives us 10. And then apply that to our numerators. 2 times 2 is 4. 7 times 1 is 7. So in our fraction on the left, we multiplied 2 times 2 and 5 times 2, which means that 4/10 means the same thing as 2/5. And on the right, we did 7 times 1 is 7, 10 times 1 is 10. We multiplied both numerator and denominator by the same thing, so of course 7 tenths means the same thing as 7 tenths.